Hey everybody, this is Alex Merced from alexmercedcoder.com, and the purpose of this video is just to kind of understand what's happening when you update your state in React, like why you have to do certain things in a certain way. Okay, so what I'm going to do is I'm going to create two squares. Actually, I think I just want to create two squares. Okay, so this square right here is going to represent your DOM. Okay, so that's going to be your DOM. Let's just put the text where we want it. I want it there, and I want this there. Okay, and we'll have another one of these. Okay, and this is going to be your virtual DOM. So one of the things about React and many front-end libraries is that they use what's called a virtual DOM. It's basically, the DOM is what you see on the screen. So when you already see like the buttons and the divs and all the H1s, that's the DOM. But what they do is they have a virtual DOM to make sure that we're not rebuilding your whole website every time you update something. Okay, so let's pretend that this website has, okay, a couple shapes. So here we say we have this shape, and this shape is, we're going to call it 1. Okay, now we'll center that. Okay, call this 1. 2 and 3. Okay, so that's essentially like, imagine like 3 divs. Okay, these are 3 divs, and then you are setting the color in it using state. So then you have state. Oops, Control Z. Okay, so we'll say this is your state. And again, state is just data, but certain data that you designate is saying, you're telling React that this data is important to how my component looks like. Okay, so when this data changes, you need to rebuild this thing. So if I put this here, let's just say that your state 1 equals red, 2 equals green, and 3 equals blue. Okay, so then the result is that React, the first time it renders it, because this is, let's say this is the initial state, so this is what you start the state out as. Okay, so that means 1 is going to be red. This is an example. So this is red. This one 2 is green, and then this is blue. Okay. Let me just copy these pieces over. Now let's say you decide that you want to update your state. So before any actual updates happen, so let's say I decide to change my state, and I decide to change 3 to yellow. Okay, so I updated my state. Now I don't actually edit the state. I never actually change the state. So you notice that here, the state is still blue. What you're really doing is that you're triggering a render in the virtual DOM of a version of the component with the new state. So here's your new state where it's yellow. So then what happens in the virtual DOM, it's going to recreate that component, except now it's this part's yellow. And then it compares the two. And it says, okay, are these two the same? Well, when it looks at it, it's like, no, it's this. You ended up with something different. Okay, the only part that's different though is this part. So the only part it actually ends up updating is this part. And the rest of the DOM goes unchanged. And then what it does, it ends up throwing away this old state and replacing it with the new state. Okay, so technically this is essentially a new version of your component. The old version is gone. The old state's gone. You never updated the state. So again, this never changed. This object never was changed. You just replaced it with a new object with new data. So whenever you're calling that SetState function, that's all you're doing. And as an intermediate step, it first makes a comparison between sort of that old object, okay, and the new one. Okay, so now one thing you got to be careful for is, again, you have to use the SetState function. So imagine if I did this. So let me move this yellow back over here. Actually, I'll get rid of that. Let's move this blue back for a second. Okay. And I'm going to put this here for a second. So imagine I did this instead. What if before I called this, instead of passing the new state to the SetState function, what I did is I first changed this to yellow. I just manually changed it by saying, okay, hey, 3 equals yellow now. And then I passed it to the SetState option, the SetState function. I end up, it's still going to be blue. Why? Because the virtual DOM is taking a look at the new state. And when it looks at the new state compared to the old state's still the same. So even though this was rendered when it was blue, you change this to yellow. This object now says yellow. You've passed in a new state, and now these two states are still the same. So the component won't rebuild it because it doesn't know. Okay, it doesn't know the difference between colors in yellow. It just knows the old state versus the new state. That's why you never edit the old state. You never directly change it to avoid that problem. Okay, because the idea is you want it to stay blue. So what you do is you pass the new state to SetState, and then the comparison happens, and then that's how React decides, oh, I need to rebuild this because the new state is not the same as the old state. And that's essentially what's going on in the virtual DOM. It's comparing props and it's comparing state. So if a component's props, so basically when the virtual DOM is going to rebuild that component and all of its children and then compare it to the actual DOM. Any component who had a change in state or a change in props is going to get re-rendered. Okay? If there isn't a change in props, if there isn't a change in state, then it will not re-render. And it will only re-render the parts that actually would change. So as we saw earlier, this turned into yellow. That was the only thing that changed, so that was the only part that got re-rendered. The remainder of the DOM was left unrendered, and that's kind of how it optimizes performance. Okay, so that way you're not rebuilding the entire DOM every time the state changes, only the parts that actually would be updated. And that's the benefit of splitting it up to as many components as possible. Okay, because if, you know, basically, if all the parts that don't change are in different components, and basically like the parts that would actually be affected by a change in state and change in props are as minimal as possible, you're going to end up having the most efficient renders possible. So that's just kind of hopefully helps you understand sort of the logic of state in React. But this is the same logic as like data in Vue or just variables in React and Angular, or just state in any of these front-end frameworks. Because at the end of the day, it's all these frameworks are aware of are the component. And it wants to try to optimize not rebuilding the entire component and all of its children. Now, of course, if you were to just do this imperatively and just use like something like jQuery, or just use plain old vanilla JavaScript, and basically manually sit there and say only change this when this data changes, that's going to be much more optimal. That's kind of what Svelte does under the hood. So Svelte, you use a compiler, and since it maps like those relationships, so the ending code is kind of more efficient. But Svelte came along a lot later than React, Angular, and Vue, which is why it's still sort of a smaller framework. But the idea is that instead of having this whole virtual DOM comparison thing happening every time, you know, it just knows, okay, these are the places where I use that variable. These are the places where sort of DOM manipulation occurs in plain vanilla JavaScript if this variable changes. Which is what leads to sort of Svelte sort of super speed at runtime and at build time. At runtime and on first paint, meaning the bundle size is small. So now I'm kind of getting off on a tangent, but hopefully you guys enjoyed this. My name is Alex Merced from alexmercedcoder.com. Subscribe to the video, hit like, go subscribe to the Slack and Discord channel over there at devnursery.com, and I'll talk to you guys later.